If pointers feel confusing, it is usually because memory is not clear. So, before mastering advanced pointers, let's deeply understand how memory actually works. Hello everyone, welcome to oneShot Coding. This is the part 2 of pointers. So if you have not watched the first video, I would suggest all of you to check the first video. Let's start. Computer memory is divided into extremely small units called bytes. 1 byte is the smallest directly addressable memory unit. So if we create a variable of integer type, we know that it typically occupies 4 bytes of memory. Let's see how it occupies 4 bytes of memory. So here I have created a variable integer x equals 5. So we will see how this will be stored inside our memory. As we know that it is going to occupy 4 bytes of memory. So inside the memory, here in this memory diagram, I have created each block of 1 bytes. So it is having 1000 for the first block, 1001 for the second block, 1002 for the third block, and so on. So each block contains 1 bytes of memory. So for this variable integer x equals to 5, this variable will occupy 4 block of memory. So the variable x is going to occupy 4 blocks of 1 bytes of memory, and our 5 value will be stored here. So each block gets grouped together and our variable data gets stored, and it contains the address of first block always. So if it is grouped together, it will always have the address of the first block. So our x variable will contain address 1000 in this case. If we create a character variable, so suppose we are creating a character c equals k. So we know that character occupies 1 byte of memory. So somewhere here, suppose here our c is getting stored, it will occupy 1 block, 1 byte of memory, and our k will be stored here. This is how our data gets stored inside the memory. Now, every byte in memory has its own address. But when multiple bytes combine to store a variable, the variable gets the address of the first byte. This is an important point we should be clear about. Now, let's see the relationship between pointer and variables. I have written a one point here. Changing value using pointers also change original variable. Now what does it mean? Here we are creating a variable integer x equals 5, and the same variable suppose we have inserted in our memory. Then we are creating a pointer integer star p. In this pointer we are storing address of x. So we know that the address of x is 1000 because it will contain the address of the first block. This address will be stored inside p. So once we create p variable, it is a pointer variable. So it will occupy again 4 bytes of memory. So suppose here our pointer p gets created. This is our pointer p. And in this block now I can store the address of any variable. So in our pointer p, we are storing the address 1000. So this contains 1000. So our p is pointing to this address 1000 of variable x. Now if we write star p equals 20, so we are saying that star 1000 equals to 20. So what is the value at 1000 right now? So if we go to 1000 address and we see the current value of 1000 is 5. So we are updating this value to 20. So we can go to the address of a variable and we can update the values using our pointers. Second point, we should always initialize our pointers to null. You can see this line here. We are writing integer star p equals null. Why? Because if we do not initialize our pointers, it contains garbage data. Okay, and while dereferencing it, it can create some unpredicted results. It can cause crash in our programs. So we should always initialize our pointer to null. We should not just declare our pointer like this. Suppose we have written integer star p. and done. We should never leave our pointer like this. We should always initialize this to null. Now, let's move to our next main point, pointer arithmetics. Before moving, let's quickly see the code of this pointer and variable relationship. Then we will move to our second topic, pointer arithmetics. So, we will create a variable, suppose integer a equals 10. And I will create a pointer integer star p. In this pointer, we will store the address of a. Now, if we go to this star p equals 20. So, we are saying that whatever the address of a is available in the p, go to this address and update this. Now, if I print this, let's see the output. So, if we print the variable a, so initially our a is 10. Let me print this variable here also before updating. So, I will write printf %d and a variable. So, what we are doing is we created a variable a, in this we have added 10. Then we are creating a pointer. In this pointer, we are storing address of a. After this, we are just printing our a. Let's add /n, so it will move the cursor to new line. Then after this, we are going to this star p equals 20. So, we are going to the address of a and we are updating it to 20. And after this, we are again printing our variable a. So, we'll see the output quickly. So, if you see the output below here, the first output is 10 and the second output is 20. So, previously our variable was 10, so 10 has been printed. After this, we updated this a using our pointer to 20. So, the next output is 20. Hope this is clear to all of you. Let's move to our next topic, pointer arithmetics. Now, pointer arithmetic becomes almost obvious. We'll understand very in depth how pointer arithmetics work, why pointer arithmetics are important. Arithmetic operators we all know. So, same arithmetic operators we can apply on our pointers. But there are only limited operators that we can apply on our pointers and other operators we cannot apply. So, we'll see what are the operators we can apply and how it works, and what are the operators we cannot apply and why we cannot apply on the pointers. Let's first read the definition of our pointer arithmetic. So, pointer arithmetic refers to performing arithmetic operations on pointer variables to navigate through memory locations, mainly within arrays and contiguous memory blocks. So, majorly pointer arithmetic we use to access our contiguous memory blocks and access our arrays. It allows us to traverse arrays. So, with the help of pointer arithmetics, we can access our array elements similar to how we access using indexes. But in pointer arithmetics, we will access array elements using the address, not the indexes. Second, it helps us to access elements dynamically. So, we can access now the elements using the memory address with the help of pointer arithmetics. It is also used to build efficient data structures like linked list, stacks, queues. And it also works with dynamic memory allocation. While allocating the memory using malloc, calloc and realloc functions, we use pointer arithmetics for traversal and other operations that we are going to cover in our next topics. Now, before moving to the code of pointer arithmetic, let's understand a basic and golden rule of pointer arithmetics. When you do addition or subtraction of a number n to a pointer, so when we are adding or subtracting any number to a pointer, the pointer doesn't move normally. It moves like n into size of data type bytes in the memory. Here I have written a formula n into size of data types bytes in the memory. Now what does it mean? Let's see. Normal mathematics, if we do pointer plus 1, suppose I have written a example integer star pointer. In this pointer it is having address 1000. Now if we do pointer plus 1, so normal arithmetics it should be 1000 plus 1 and it should become 1001. If we write 1000 plus 2 star ptr, if we are writing ptr plus 2, it should be 1000 plus 2, 1000 plus 2 and we should get 1002. But it doesn't works like that. How it is solved, we'll see here. I'll quickly explain you how it works. So if we are writing pointer plus 1, so we are writing pointer plus 1. It will be solved like this. So suppose this pointer is having 1000 memory address. So 1000 plus our formula n into size of data type. So our n is 1 here. 1 into size of data type. So if it is an integer, we know that the size of data type is 4 bytes. So 1 into 4. So it will give us 1004. If we are writing pointer plus 2 in case of integers, so again 1000 plus, here I left plus, okay, 1000 plus n into size of data types. So here our n is 2. So 2 into the size of integer is 4 bytes. So 2 into 4. So it will give us 1008 address for integers. So every time we are doing pointer arithmetics addition, this formula gets applied and our pointer moves to the next block of memory. So we should remember that our pointers move by the size of its data type. So if it is an integer pointer, it will move 4 bytes. If it is a character pointer, it will move 1 bytes because we know our character occupies 1 bytes. If it is a float pointer, it will move 4 bytes because float occupies 4 bytes of memory. Okay. Now we'll see more about this in arrays while discussing pointer arithmetics with the help of arrays in the next slide. Let's move. We'll see pointer arithmetics with arrays. Before this, here I have created a character pointer. So character pointer, if this pointer is having 1000 address, so and we are writing pointer plus 1, so it will be like 1000 plus n is 1 right now and size of data type, size of character data type is 1 bytes only. So 1 into 1. So it will move to the 1001 address. It will give us 1001 address. This is how pointer arithmetic works. Now let's understand how it works with arrays. Here we'll see I have created an array of size 6 and inserted 6 elements in this 10, 20, 30, 40, 50, 60. We are creating a pointer integer star ptr and in this I am storing the address of ARR. We are assigning the array name. Okay. Now what happens? Array name always points to the first address of the first element. This is also called a base address. Our array name always contains the base address. This is the address of the first element. So if we are writing integer star ptr equals to ARR, so you can see that the address of first element is 1000. So this 1000 will be stored in our pointer. So here 1000 will be stored at the pointer variable. Now if we print star ptr, so star ptr we already know that we are saying value at ptr. So what is the value at? We are saying star ptr means this line. We are saying what is the value at 1000. So at 1000 address, we know that we are having 10 value. So it will give us 10 output. Now we can move to the array indexes or array elements using the pointer arithmetics. We'll see how we can access each array element using pointer arithmetics. So previously we were accessing elements with array indexes, but now in this array each element will have its own address. So the first element is having 1000 address. It occupies 4 bytes of memory because it is having integer value. Then I have given the next address 1004 because the 10 is integer and integer occupies 4 bytes of memory. So our first block will occupy 4 byte of memory. Then after this, same like previous one, the second element 20 is also integer. It is also going to occupy 4 bytes of memory and it will have the address 1004. 1000 from 1000 to 1004, first element is occupying. After this 1000 till 1004, from 1004 to 1008 it is occupying. From 1008 to 1012 third element occupies. So third element address is 1008, fourth element address is 1012, fifth element address is 1016 and sixth element address is 1020. Now let's understand how we can access the array element using pointer arithmetics. You can see here the second line we are writing is integer, we are saying star ptr plus 1. Now what happens if we write star ptr plus 1? As we discussed in the above slide, if we are writing star ptr plus 1, so we know that in ptr 1000 is there. So we are saying star 1000 plus, again here 1 n into size of data type. So 1 into size of data type is 4. So it will give us star 1004. So we are saying what is the value at 1004 address. So we have moved to the next element. If you will see, 1004 is the address of next element, second element. So what is the value at 1004? So it is absolutely going to give us 20 value. Okay. Now if we are writing star ptr plus 2, so how it will be solved? Same like this. It will be solved star 1000 plus 2 into 4. So it is going to give us a star 1008 address. What is the value at 1008 address? We again move to the next element address. So the value at star 1008 address is 30. So 30 will be printed. Now same like this, I can move to each element of the address using the pointer arithmetic and we can print the values. So if I want to print the fourth element, I can go to this address 1012. So we can write star ptr plus 3. If I want to print this one, we can write star ptr plus 4. If we want to print the next element, we can write star ptr plus 6. And we can access each array elements using the address of the array elements now using pointer arithmetics. Let's quickly go to the code editor and we'll write the code of this and we'll print the values. Okay, so now we'll write the code and let's see what are the values getting printed. So we are going to create first a array of size 6 and in this array I am going to assign the values 10, 20, 30, 40, 50 and 60. So we created an array and in this we have assigned all the values. Now let's create a pointer. So we'll write integer star ptr. In this pointer I am going to assign the address of our array. So we are assigning the address of array in our pointer ptr. Now let's start printing the values. So we will write printf %d /n comma, let's print what is the value in pointer. After this we'll print using the pointer arithmetics ptr plus 1 as we discussed in the slide. After this let's print one more value ptr plus 2. And in the last we'll write return 0. Let's run this code quickly and let's see the output. So we'll run our code So I will write the commands to run the code. Now let's see the output. We are getting 10, 20 and 30. So the first output we are getting from here. I told you guys that if we assign the name of array in a pointer, it gives the address of the first element. So while dereferencing it, what we are saying it, give me the value at the address is stored in the pointer variable ptr. So if we are getting the output 10, we can understand that we are having the address of 10 inside our variable ptr. Then only if we are dereferencing it, it is giving us the value 10. Same we discussed on the slide also. Now, if we do star ptr plus 1, it is giving us the value at next element. Then if we are doing star ptr plus 2, it is giving us the value at the next element. So here, whatever the address is of pointer, we are doing plus 4 bytes. Then here also, whatever the address we have, we are doing plus 8 because we are passing 2 here. I hope this is clear to you now. Now, for the same thing, I will explain one more topic and then we will move to our next slides. Let me go back to my slides. Here I have written a line, difference between star ptr plus 1 and star ptr plus 1. So here, what is the difference if we write star ptr with brackets? And what is the difference what if we write the same thing without brackets? So you can get confusion in this. So we should understand the difference between both. If we are writing star ptr plus 1, this one we already know it gives us value at next address. So if it is an integer and our pointer star ptr is containing the address 1000, we know that this is going to give us 1004. But if you are writing the same thing without brackets, so here star ptr will be solved first, star ptr. So whatever the value at the pointer, so in this, suppose we have a variable integer a equals 10 and we have given the address of ptr equals to address of a. We have given the address of a in this pointer. So first, if we are writing star ptr plus 1, so here this thing gets solved first. So it will give us 10 first. If it is having value 10, star ptr means what is the value at this address. So it will give us 10 then plus 1. So the output we will give is 11, not the next address. Output will get 11. So this thing you should always make sure while writing or while using pointer arithmetics that we should write this inside our brackets. And these questions can be asked in your interviews also. So this thing you can practice, you can write the code in the code editor and practice once. What is the output coming if we are writing star ptr plus 1 with brackets, and what is the output coming if we are writing the same thing without brackets. So here I have written the point also that the first one will always give us value at next address, while the next one, second one will give us value at pointer. So the value at pointer was 10, then plus 1, then plus 1. So 10 plus 1 will get 11. Now, in pointer arithmetics only, we have other arithmetic operators, increment and decrement. We can perform increment and decrement on pointers. So we know that we have increment operator like pointer plus plus, pointer increment. So if we are writing pointer plus plus and my pointer is 1000, my pointer is storing address 1000 and we are doing pointer plus plus, it will move to next element. What it means this is, if we are having the address of an integer variable inside the pointer, then it will move to the next element address 1004. Okay, and if the same thing we are using pointer decrement here, if we are having the same 1000 address and it is of integer, it is containing the address of integer variable and we are writing pointer minus minus, so 1000 minus 4 will happen. Okay, so we will get something 996 address. So it is very easy, we should remember this. If we are using pointer increment, it moves our address to the next element, and If we are doing pointer decrement, pointer minus minus, it moves to the previous element. So pointer plus plus will move my element to the next element, next address, and pointer decrement will move my element to the previous element. So this is our increment and decrement arithmetic operators we can perform on pointers. Now apart from this, other arithmetic operators are not allowed on pointers. We should remember this. Okay, what we cannot do on pointers, we cannot do the addition of two pointers. Suppose I am having integer star p1 and star p2. So I cannot do p1 plus p2. Addition of two pointers are not allowed. Why? Because if we are adding to memory address, pointer contains memory address, right? So if we are adding to memory address, then it can give us some wrong memory address while we are adding both memory address. So that's why this is not allowed first. Then we cannot multiply also in a pointer. So suppose we are having a star p1, I cannot do p1 into some number 2. This is also not allowed. Then third one, we cannot perform division also on our pointers. Same, we'll take the example of p1 pointer. I cannot write p1 divide by 2. This is also not allowed. This is also not allowed. This is also not allowed. Then pointer modulus number. Modulus up. Why this one is not allowed? Because it can give us some decimal values. Okay. And we do not have decimal values in memory address. So not allowed. Then pointer modulus number. I cannot do p1 mod 2. Not allowed. Why? Because this modulus works on constant values. It works on integers, numbers. It doesn't works on memory address, and our pointer contains memory address. Because of this, these all our arithmetic operators are not allowed on pointers. Pointer plus float also not allowed. So we should remember, we can perform only addition, we can perform only addition, we can perform subtraction, and we can perform increment, decrement. Increment, decrement. Only these operations we can perform on pointers. All of these operations we cannot perform. You should remember this. Okay. So this was all about our pointer arithmetics. Let's move to our next topic on pointers only. Now we are going to see the difference between call by value and call by reference. There is the importance of understanding these topics with respect to pointers. So first, we all know that what is meaning of calling a function. When a function is called in C, arguments are passed to the function parameters. Correct? So we are having some function, and once we call a function, we pass some arguments to this. Right? How this argument is passed? This is the way these arguments are passed. It defines whether the original data can be modified and how memory is used. Our data gets passed in two ways. Okay, the first one is called call by value, and the second one is called call by reference. Call by reference, we use pointers. So this is important. We should understand why we use call by reference. Okay. So I will give a quick review what happens in call by function and what happens in call by reference. Our first one is call by value. Now let's understand how our data gets passed in call by value. In call by value, a copy of the actual variable value is passed to the function. Our function works on a separate memory location, and the original variable remains unchanged. Our original variable never changes. Okay. If we see the example of this code here, okay. So in the main function, we are having a variable a equals 5. We are calling a function update. In this function, we are passing a. After this, we are printing our variable a. While we call this function, it will go to this function code, and this function code will run. So in this function, we are creating a function update. We are passing a parameter integer x. So Here in this function call, let's understand what happens. This is called by value. So here if you are passing this a inside this original a never gets passed. Okay, original never gets passed. Once we pass this variable a copy becomes created, copy. A copy of this variable a gets created and this copy gets passed to our function a. Okay, so this a is 5 right now. So we will get the value 5 here, integer a. This a will be passed here 5 in the function update. Here in this function we are updating x equals 10. So we are updating this value 5 equals 10. So in this function the value has been updated, but inside the main function it remains the same value, it will not change. So if we are printing a, it is going to print us 5 only, not 10. This is call by value. Let's understand this with the help of a diagram. What happens in call by value? So this is the memory block of our main function. Once our main function runs, in this we are having a variable a and a equals 5. We have given the value 5. Once we call the function update, this a copy of a gets created here. So you can see this variable is in different place and a copy of this a has been created, okay, and it is get passed to x. So x is having 5 now. This is different. This is different. Now this copy is getting passed to the function update. In this function, the copy of a is getting passed. So in the update function, we have a local variable x. So we created a variable x in our update function. In this, we are updating the x to 10. So this 5 gets updated to 10. So you can see here, this is separate memory location. First point, this is a separate memory location. Separate memory location. And our main function runs on separate memory location. This one, both are at separate memory locations. And this variable a is never passed to this update function. The copy of a gets created here and this gets passed to x. And this x we are changing in update function, which is a separate memory location. And there's one more concept of local variable. This x is a local variable to the function update. So here if we are changing the value of x, you can see that we didn't updated a here. There is no change in the variable a. We updated x here, so our x has been updated in this. So if we try to print the x here, it will be 10. But if we print a variable here, it will be 5. So the value will never be changed. So in call by value, it passes copy of the variable to the function arguments or function parameters. Let's run the code and we'll see the output of this code. And then we will see what happens in call by reference with same code example. So let's quickly go to our code editor. In the code editor, we will create a variable integer a equals 5 and I will call the function update. In this function, let's pass our argument a and then let's print. Let's print what is the value getting printed here. Okay, we're just printing our variable a. Now let's create our function, update function. So we'll create a function void update. In this function, we have integer x parameter and I am updating this x to 20 suppose. And let's print here also printf %d slash n x. Okay, and here also let's give slash n. Let's run this code and we'll see what is the output coming. So you can see the output. So first line here, how our code will run? The first line will run, it will create a variable integer a equals 5. The second line will run update. We are calling the function update. So it will go to this update code and it will run the update function code first. So here we are passing the argument a into the parameter of update function x. Here we are updating this x to 20, and once we print x in this function, we are getting the output 20. So in this is having a separate memory location. This function code has separate memory location, and our integer main function is running on separate memory location. So in this memory location, this x is local variable and it contains value 20. And in this main function, our a was never changed. Okay. So once we are printing a variable, it is giving us the value 5. So here if we pass this variable a inside update function, the original value never gets passed. Copy of the copy of a gets passed to the function update. Okay. But at some time we want that if we are changing our value in some function, that should be changed inside our main function also. What I am trying to say is, suppose here we updated 20, we want that this a should be changed to 20. So how that can be achieved? Okay, that only we are going to see in our next slide, call by reference. So let's move to call by reference now. Let's quickly move to call by reference. Now let's understand what happens in call by reference. In call by reference, the address of the variable is passed to the function. Address of the variable is passed to the function. The function accesses original memory using pointers. And whatever the changes we will do inside the function, that will reflect in the calling function also. So here our calling function is main. Inside main we are calling our update function. So if we are doing any change in the update function, that change will be visible in our main function also. Okay, let's see the example code. Now here what we will do, same, what we will do is we'll pass the address now. Okay, so what here, instead of just passing the variable a, we'll pass the address of a. In update function we'll pass address of a. Okay, and if we are passing the address of a, sorry, here if we want to pass the address of a, we need to give ampersand symbol, not a star. So we are giving the address ampersand address of a. So variable a address will be passed in the function. Now if we are passing the address, we need to store it in a pointer. So this variable we need to convert into pointer, and inside this now I am saying whatever the value at this address, update it to 20. Now let's run this code and let's see the output. After this I will explain you with the help of diagram also, don't worry. So let's run this code, dcc pointers.c. So here what are we printing? We are printing a. Okay, and printf star x. Let's print the value at x. gcc print pointers dot c. Okay, now you can see that here also we are getting 20 and here also both the outputs are 20. Now what we did, let's understand this with the help of a diagram. Okay, here only I will explain you. So we created a variable integer a equals 5. Let me change the color quickly. So suppose once we create a equals 5, a container gets created of 4 bytes. So this is our a, it is having the value 5, and let's assume the address is 1000. Okay, then in this we are passing now address. So we are passing address 1000. Okay, so once we call this function, it will go to this function code. Okay, and we are storing the address in the pointer x. Now in pointer x it is having 1000. Now what are we seeing here? We are saying that go to this 1000 address and update it to 10. So we are saying go to this 1000 address, value at 1000 address. What is the value at 1000 address? Update it to 10. So it is going to this address and it is updating our value to 10. So if we print here also, now our output will be 10, and inside main also our output will be 10. This is only called call by reference. In call by reference, instead of passing the copy of the variable, we pass the address of the variable. Okay, this is very important in data structure points of view, because in data structure points of view, we'll access the memory address and we cannot suppose we want to do any changes. Okay, so in the function we'll pass the copy, so any change it will happen in the copy file, that will not reflect inside our main file. Okay, that we don't want to happen. So to avoid this, we will be using call by reference in our data structures while implementing our linked list, stack, queues. Okay, so for this reason only it was important to understand call by value and call by reference. Now I will quickly move to the next topic. So here I have written the point why DSA requires call by reference. So I would like you guys to practice this code of swapping of two numbers. So in swapping of two numbers, if we create a function swap, in this we are taking two variables, integer a, integer b, and we are taking a temporary variable. In this variable we are assigning a, then we'll update in the a, we will store b value, and in b we'll update temp. So our value normally gets updated. Like, so if you run this code and you print the values inside main, you will get that the values are not getting swapped. So whatever values are getting swapped here, it will not reflect in main function. Inside main function, it will not reflect. So for this, we have to use our call by reference. So for the same function, again, if we try using call by reference. So in call by reference, what we will do, we'll use pointers, and inside main function, instead of just passing a, b variables, we'll pass address of a, we'll pass address of b in the function swap. So in swap function, you need to pass address of a, address of b, and then you write this code. Now whatever the changes we are doing here, because we are passing the address of the variables now, then the changes will reflect in our main also. I will share the codes also below, so you can run this code and you can check it once. I will quickly move to the next topic, pointers and arrays. Arrays concept I already explained you above also, but let's see some other points with respect to pointers and arrays. The first point is array name act as a constant pointer to the first element. Our array name. So here I have created an array. This ARR is my array name. It works as a constant pointer to the first element. Okay. Array name stores the base address. I explained you guys that this array will always store the address of the first element. That is only called the base address. Okay. So our array name is a constant pointer. It is a pointer. Okay. Our array name acts as a pointer, and it contains address of first element. Always it will contain the address of first element, that is only called the base address. So it contains base address. Then pointer can be reassigned. Our pointers can be reassigned, but array name cannot. In pointer we can reassign it, we can again give the address of some other variable, but in array we cannot reassign. Okay. Then pointer arithmetics is used to traverse arrays. We have already discussed this, that we can access each array element with the help of pointer arithmetics. Now next point, ARR at I. This is an important point we should understand. ARR at I. We are saying ARR at I is equivalent to star ARR at I, ARR plus I. Whenever you are writing ARR at I, in behind it works like this, star ARR plus I. Always. So if we are saying ARR at one index, in behind it runs ARR plus 1 or 1 into size of data type. Okay. So if we write ARR at I and if we write star ARR plus I, both are same. Okay. You can see this example. In this example, the first one, we created an array of 5 elements. We created a pointer. In this pointer, we are assigning the address of ARR. Then we are printing star P. Then we are printing star P plus 1. And we are printing P at index 2. Right. So P at index 2 will give us 30. And if we write star P plus 2 also, it will also give us 30. So both are same. If we write P at index 2 or if we write star P plus 2, both are same. If I write star P plus 2, both are same, because in behind, if we are writing P at 2, our compiler runs it like this only. It doesn't runs like this, because our array name is a constant pointer and it contains address of the first element always. So this point we should remember. Now I will quickly move to the next topic. Now let's see our last topic, double pointer. What is a double pointer? A double pointer is a pointer that stores the address of another pointer, allowing us two level of dereferencing. Let's understand it in a very easy way. Okay, so till now what we are doing is we can create a variable, and if I want to store the address of this variable, I can create a pointer, and in this pointer I can store address of a variable. But we know that our pointer also contains the address. So if I want to store the address of this pointer, then I cannot store this in a normal pointer. I have to create a double pointer. And in this double pointer, I can store address of the normal pointer. Now let's see the syntax. So syntax is almost same like our pointers. Here we'll write data type. Instead of giving 1 star, we will write 2 stars. And then we will give a pointer name. Let's understand this with the help of an example code and diagram. So here I am creating two variables, integer a equals 10, b equals 20. So once we create two variables in memory, a block of, it will contain a block for a. So this is our a, and suppose the address of a is 1000. Then for b also a container will be created, and suppose the address of b is 2000. After this, I am creating 4 pointers. Integer star p, I am creating a normal pointer. So here a container will be suppose created for our pointer p, and let's assume the address of the pointer is 3000. Then we created a pointer q, star q. So here a container gets created for pointer q, and in this suppose it is containing address 4000. Now I am creating a double pointer ptr1. So same like normal pointer, a container will be created for double pointer also. So this is our ptr1, and let's assume the address of ptr1 is 5000. It will also contain address same like a normal pointer. Then we created a double pointer ptr2. So here our container gets created for ptr2, and the address of this is suppose 6000. Okay. Now let's start assigning the values. So in my pointer we know that I can store address of some variables. So my p is a normal pointer. In this I will store the address of a. So what is the address of a? Address of a is 1000. So this 1000 will be inserted in this. And our a is having first 10 and 20. So inside a we have 10. Inside b we have the value 20. Now in my pointer p I stored the address of variable a, right? And in the q pointer we are storing address of b. So the address of b is 2000. This 2000 will be stored in my q pointer. Now we know that in double pointers, my ptr1 and ptr2 are double pointers. I can store address of a pointer. So my pointer p is my pointer, right? So what is the address of pointer p? 3000. Now we are saying ptr1 equals to ampersand p. So this 3000 we are inserting inside our double pointer. This is only a double pointer. In this double pointer, we can store address of a pointer. But in a normal pointer, we store address of a variable. So 1000 is address of a variable. So 1000 we inserted inside P. But this 3000 is address of a pointer. This address I am storing in a double pointer. In ptr2, we storing address of Q pointer. So the address of Q pointer is 4000. This 4000 we are inserting in our double pointer. We are done. Now here I have written a point. It allows us 2 levels of dereferencing. Now it is an important point we should understand with pointers. Here some of you can get doubts, but in one time only your doubt will be clearer. So now we are printing. While printing, we can write 2 stars. We can add 2 stars and ptr at 1. So what will happen if we are writing star star our double pointer name ptr1? Okay. So how this will be solved? Let's understand this one. Okay. So if we write star star ptr1, here 2 level of dereferencing happens. First, this one will be solved. Star ptr gets solved. So what is if we solve star ptr? First I told you star ptr will be solved. So what value we will get at star ptr? Where is our ptr? Star ptr1. So my pointer name is star ptr1. Star ptr1 means value at ptr1. Okay. So ptr1 is containing 3000 address. So we are saying what is the value at 3000 address? What is the value at 3000 address? So star ptr1 value at ptr1. So in ptr1 we are having 3000 address. So star ptr will give us what is the value at 3000. Okay. So the value at 3000 is 1000. So we will get 1000. This is the first level of dereferencing. Then second level of dereferencing will be star 1000. So we got 1000 here. Now second level of dereferencing star 1000. So star 1000 will give us what is the value at 1000 address. We know this. What is the value at 1000 address? So what is the value at 1000 address? We already know. The value is 10. So 10 will be printed. Okay. Same like this. So you can see here what happened. First we went from here till here. This is the first level of dereferencing. Then second we went from here to here. This is the second level of dereferencing. That is why it was mentioned that it allows us 2 level of dereferencing. Okay. Now same thing if we do star star ptr2, not 1. Here if we do star star ptr2. So first we know that star, let me move down. Okay, wait. Star, here I will write star star ptr2. In ptr2 I told you 2 level of dereferencing will happen. First star ptr2 will be solved. So star ptr2, what is the value at ptr2? So what is the value at this? My ptr2 is containing 4000. What is the value at 4000? So we know that at 4000 we have value 2000. So here we will get 2000. This is first level of dereferencing. Second level, it will solve star 2000. So now we are saying what is the value at this 2000. So we know that this is the 2000. The value at 2000 is 20, right? So we are moving here. So it is going to give us 20. Okay. Now what will be the output if we print star p? We know that star p means value at p. So p is this one, right? P, value at p. So this is going to give us 10. Inside p we are having 1000. What is the value at p? Value at p is 10. We'll get 10 output. Now what is star q? If we print star q, we are saying what is the value at q. So inside q I am having 2000 address. What is the value at 2000 address? We have 20 value at 2000 address. Okay. So I hope this is clear to all of you. Let's quickly write the code and we will see the outputs. So let me remove all of these codes here, and we will remove this update function also. Let's create two variables, integer a equals 10, b equals 20. Then let's create integer star p star p. We are creating how many pointers? We are creating 4 pointers. So star p star q star pointer 1 and star pointer 2. Now pointer 1 and pointer 2 are double pointers. So double pointer syntax is, first we'll add 2 stars ptr1 ptr2. If we are getting confused, I will write, so here we'll write something like this, integer ptr1. This is how we'll create a double pointer. Okay, so let me remove this one. Now let's assign the values. So in p we'll store address of a variable. In our q pointer we'll store address of b variable. Now in double pointer ptr1 I will store address of p pointer, and in double pointer ptr2 I will store address of q pointer. Now we will start printing one by one. So let's first print star star ptr1. So 2 level of dereferencing will happen, same like I explained you. Now let's print star star ptr2. We will also print what is the value getting printed at star p. So we'll print star p, and we will also print star q. Let's quickly run this code. So let me write the commands. So you can see the outputs. Star star ptr1 is giving us 10. 2 level of dereferencing is happening, it is giving us 10. Star star ptr2, it is giving us 20. Now star p, what is the value stored at p? So in p we are having address of a, and a is containing 10, so we are getting 10. Now what is star q? So in q we are storing address of b variable. So what is the value in b variable address? So b is containing 20, so 20 is getting printed. I hope this is clear to all of you. So this is all for today. In the next lecture, I will be explaining types of pointers. I will be giving you all the codes in my GitHub, and I will be sharing the links below. Also, I will share my Telegram link. You all can follow and join the Telegram link. In that also, I will be sharing all the notes. After this, we will also cover some questions on pointers that I will be sharing. That's all for today. Thank you all.